Hey everybody, Dave from Design to Make a Difference. I want to circle back with you all from our January 18th professional development. We were really excited about that day, especially with the addition to the computer science component. Bringing on Dave Nassar, our colleague at Winchester. He's real excited about being part of the program as well, and we're excited to just add this new component. With this new component, we know it's going to be a challenge for us all. It's brand new to many of you. It's fairly new to us, so we're going to do our best to educate you as well. And one of the ways that we said that we could really help is by making some short videos each week. So give you some ideas and some challenges and some thoughts on how microbits can be used, a connection to what we do in some of our trainings, and then some new things as well. I thought today's video could be a connection to the end of what we did in the training with the line tracker and get that working, and also talk a little bit about that functions idea within the code to give that best structure of code as well to help us build for the future. I have a couple of things that I've found that are some handy new techniques when running the robot. I think it'll be helpful as well, so we'll build from that. So let's get started. I'm in the Microsoft Microbit editor, I guess you want to call it, the Make Code editor. This is just such a dynamic web editor for coding. I'm so excited about it. In fact, I'm going to be using this with my 8th graders to do some hardware programming as well. So I'll learn even some more connection on how the students view this as well. So that's going to be exciting. I'll share those thoughts as we move forward over the next month or two. Using this, but again, you notice in the editor too, there are places to create a new project. Notice I have a lot of different ones that I've done. I've actually played recently too with a number of the already made projects and ideas. There's so many really cool things that you can do with a microbit. It does not have to just be the CuteBot. So I encourage you to go ahead and try some of these tutorials to see what they do. I created just a clapping sensor, almost like a on-off sensor with a sound sensor with some of these tutorials. Really cool things that you could do. Again, we are always open to hear what you want to do with the robot too, or with the microbit. But the robot was just kind of a cool idea and challenge that we thought we'd throw to you. So let's go ahead. Well, like I said, what I'm going to do today is build the line tracker sensor, but I'm going to do it from the start, so you can see the process again, and we'll work through that as we do it. So I'm going to go ahead and open up a new project. I'll go ahead and call it Line Tracer. I'm going to call it Line Tracer 2 on mine, just because I have another one too. But you can call it, name that whatever you like. I like that when you create a project in this editor too, they ask you to title it first. So you're not going to have a lot of untitled things. Truly talk to your students about what they should label their programs, and they'll see it as they kind of go on here too. Towards the end, I want to talk about the import-export function of this as well. But we'll see how long the video gets. I don't want to make it super long. I might make that a separate video as well. So I'm going to go ahead and create that. And as that pops up, we come up to our editor too, and you saw this in the training. Again, everything always starts with the start and the forever block. I'm gonna start with a real quick thing that I figured out today as I was playing with the robot. I think we had this issue with our LED lights, and I apologize for this at the training, but this kind of popped up, and some of our robots were not working perfectly. And I found it out simply today by doing something that was an idea I used when I upload the code, but it really did affect how the robot worked. And it was simply this. In the basic function, what I like to do every time that I download the robot is I like to put a little version number on my code. So what I did is I drug the show number out of the basic menu into the forever block. And whenever I download the code, I just change this number. Now this might sound silly, but it's just for me to know that it's a new code on the robot. I know it says downloaded when I hit the download button,
but sometimes maybe it just goes so fast. I want to know what's on there. So if I change this this number, I know that the number on here matches the code that I'm working on. Well, here's the thing that I ran into. I was running this show number in the forever block. And if we remember the difference between the start and forever block, the show number or the forever block actually is the big loop, and it runs over and over again. And when I was building my line tracer program, what was happening is the show number would actually have to load every time it would loop around to the beginning. And it was causing the lights not to read the value, and the robot would just go, off the lines. And I figured out that what I have to do is put the show number in the start block, because this only runs one time. This does not loop. This just runs right at the beginning, and it goes on the LEDs. Now, if I don't tell it to leave, the 1 will stay on the front of the microbit, but it won't keep looping through. And on my forever block, I'll be able to do the line tracer program. And that's really important, because you want those lights to always recognize where the robot is on the black line or the white line part of the track, and that one little thing was causing that to be an issue. I think it was also when we were doing the LEDs and turning those on, putting an LED in the front of that of the robot, and we were doing that again from the CuteBot part of this, which we'll load in a second. It was causing the robot to just kind of veer off a little bit. So that's something to think about. Again, we learn as we kind of go along, and that was a good learning experience for us, and for me even just today, playing with it here in my lab, in my basement. So let's go ahead and get started. We're going to build the line tracer again. If you remember from the last time, every time that you work with the CuteBot, and that's what we're doing, we have to add the CuteBot extension code to the library functions over here. Okay, to do that, we open up the advanced functions, we click on extensions, and we can simply type CuteBot in the top, hit enter, and the CuteBot library pops up. We click on it, and you'll see that come up in our library functions here. And then we have all the functions for the specific robot that we're working on here. Now, what we're going to do is build that line tracer again. And if you remember, Dave talked last time, the idea of following the line is using the 2 sensors on the front of the CuteBot to recognize, is it over black, is it over white, or is it over a combination of black or white on one side of the line or not? So really there were 4 states to the line that we had to think about. And the CuteBot really has a nice way to do that. And if we notice in here, okay, scrolling down, the CuteBot has what's called a tracking state. And the tracking state gives you 4 options. When I click on that tracking state here, okay, the tracking state gives us the option where we're all over black, and ironically they're white dots, but they are colored in, the black dots. One is open, meaning white, and colored dot. Then we have a colored dot and an open, and then one that is over just the white, okay, 2 open dots. These are our 4 states that we're looking at for our tracking state. We will use this code to create some if statements to figure out how we want to make that robot run. Okay, so I'm going to drag this over here for right now, and then I'm going to show you where the if statements are. Okay, again, we use if statements under the logic section. Okay, and what we're going to do is we're going to create 4 if statements, one for each tracking state. So what I'm going to do is I'm going to click on the if statement here, and I'm going to drag it in my forever loop. Now we're going to talk about the functions in a little bit, but right now I just want to build this in the forever loop that'll loop kind of through, and then we're going to build the function towards the end. I'll show you how that works. Okay, what we're going to do is we're going to go ahead and do the first tracking state, and the first tracking state is going to be this. I'm going to drag that tracking state into the if statement. Notice how that kind of works. I kind of like how that goes. When I click on this, a little red dot kind of shows up, and the shape matches that if statement. Okay, this is the question I'm going to ask the robot. If the tracking state is, and the first one I'm going to do is open dot closed, meaning the open dot is the white, the colored in dot is the black line. Okay, if this is the tracking state, really the front of the robot is seeing this. What I want to do is I want to make the robot turn towards the light, okay, or towards the black line, meaning that I want my left wheel, because it's going to be on the outside, to turn towards the black line. So I have to make that go a little faster. To do that, what I need to do is go back to my CuteBot library, and I'm going to go to the left and right wheel percentage code. It's really the first one. I'm going to drag that in, and I'm going to change the values here. I want to make the left wheel go faster than the right. Now, I found out I can make these go pretty fast, 50 and 20. You can make these go as slow or as fast as you want. I wouldn't make them go 190, but 50 and 20 has worked for me. If the robot seems to veer off the line, I would just lower these, maybe make it 40 and 15 or 40 and 10. But I was able to kind of get my robot going on the track using this, these two numbers, these speeds, 50 and 20. Okay. Now that is the first tracking state. I'm going to show you a cool trick. Okay. We have 4 more tracking states to do. You do not have to keep dragging from the CuteBot library and the logic library. What I can do is I can right-click on this if statement, and I could duplicate it. And notice what happens is the whole if statement duplicates. So what I can do is I could drag that new one into my forever block, and now I just have to change it. And we're going to go ahead and change it to the next state. The next state is going to be the opposite of this, which is going to be if the light is on the left-hand side and we are off on the right-hand side, then I have to reverse my idea of how the robot goes. I'm going to make the robot turn to the right. So I'm going to change these numbers to 20 and 50. And what this is going to do, it's going to make the robot, if it's on the right-hand edge of the line, it's going to turn it back to the left. So it kind of brings it back on there. Okay? These two tracking states are super important. These are what happens when the robot veers off the line. Okay? So those are the two we need as we move on the line. The next one is simply going to be if it's on the line altogether. So I'm going to duplicate this again, drag the if statement back in. Notice I'm piling the if statements on top of each other. I am not bringing them inside the individual if. I'm making them separate if statements. That's really important. Your robot will then be asking 4 different questions every time it's moving along the line. Okay? The next one I'm going to do is if the robot is totally on the line, meaning that the 2 white dots are showing up or both sensors are being read, I'm going to make that robot just go forward. And I'm going to go ahead and make it go at 40-40. Now I could probably do 50-50, but 40-40 worked for me. I found that that was a pretty good speed. And this way, if both sensors are reading on the black line, it's just going to go forward. That's great. Now, there's one more tracking state that we could use. I'll be honest, you don't need to do it, but it's worth putting on here. And I did a little differently, so I'm going to go ahead and show you. I'm going to go ahead and duplicate the last one, and I'm going to go ahead and drag that in. And I'm going to say, if neither sensors are being read, essentially the robot has veered off the line. Now, this is going to change the speed altogether. Now, there is a new speed that we can put in here, a new command. I'm going to go ahead to my CuteBot memory again, and what I'm going to do is I'm going to stop the car immediately. I don't want the car to go anywhere, okay? So I'm going to drag this out and drag this one back in. If the robot gets off the line, I want to stop. I want it to stop. And that means that the robot's probably malfunctioned somewhere, and I want to make sure it stops. That's a good one. Once I've done that, I could go ahead and get rid of this other
block here. Oh, I'm sorry, I duplicated that. We're going to delete it. Delete again. And I now have my tracking state finished. Okay? This is all we need to use to make the robot work. Okay? And there's nothing else you have to do other than load this on your CuteBot, and it should run on the robot. Everything is set here. You're asking the microbit and the robot to do 4 different cases. Okay. Now there was one other quick thing that we did in the PD, and we did it so fast it might be hard to remember. I want to show you how to create a function to build this entire program into one little small function or a small code that we just drag into our forever block. And that's a really cool thing to be able to use, and you're going to see how this goes. Okay? So what we're going to do is I'm going to click on the Advanced button. I'm going to click on Functions, and what I'm going to do is I'm going to make a function. And I'm going to call it, click right in the middle, we're going to call it line tracing. And I'm going to click Done. And I now have this separate little block over here. Okay, this is a new program that I'm going to create within a program, a sub-function within here. And what we're going to do is we're going to do something really simple. We're going to drag everything that we just created in the forever loop into this function. Now, right now, if I downloaded the program to my microbit, nothing would happen other than it would show number 1. Okay? What I have to do now is I have to call the function in my forever loop. Okay? So what I'm going to do is I'm going to go back to the functions menu, library, and I'm going to call line tracing and drag this in to the forever loop. Okay? We now have a super simple program that is going to trace the line. Okay? But the cool thing here is this function now we can use within other if statements and other sensors to do things. Instead of having to do all 4 of these things, we just have to call this one little block to drag it in. It's really good computer science code to do that. It's really clean on how we have this written right now. And the cool thing here is I can reduce this, and there's my code. All 3 things that I have that's going to make our robot trace the line. It's actually very cool. And when I open that up, I could change any of these things. And the cool thing is, if I change things here, it changes it within the function here, because that's all we're doing. This is the program that's being run here. Now remember, it will not run unless you call that function in the forever loop. But once we've done that, this is what's going to run. And that is our program. I'm getting pretty long on a video here, and I don't want it to go too much longer today with this video, but I think this is a good place for us to stop as we kind of go forward. Remembering the couple things that I talked about, making sure we don't add too much to the forever loop when we're calling some of the sensors, because that will mix up some of the things that are going on there. Knowing the 4 tracking states is really important. Modeling this. Don't make sure you don't pile the ifs within ifs. They have to sit on top of each other, straight in a line like this. And then creating that function will make that work. I hope this helps. Again, it's been working pretty well for me as I've downloaded the code onto my robot. Give it a try. If you have any questions, feel free to reach out. And this will be one of, like I said, many videos that we go forward. Again, we do these videos because at any given time you could pause, stop listening to us, do the work, fast forward, find the spot that you want. I think all of these are very helpful. So we'll put these on Design to Make a Difference website, and we'll move from there. I hope everybody stays well. Look forward to connecting with you in the near future. And if you have any questions, feel free to email any of us, and we will get back to you as soon as we can. All right, everybody. Be well. Thanks.